nanoGPT is Andrew Karpathy's minimal, readable implementation of GPT-2. The entire model and training loop fit in roughly 600 lines of clean Python. No magic, no abstraction, just the essential mechanics laid bare. The goal is simple. Reproduce GPT-2 at 124 million parameters on open web text, running on a single 8 GPU node in about 4 days, while keeping every line of code legible and hackable. The repo has 2 core files. Model.py defines the full GPT architecture in about 300 lines. Train.py is the training loop in another 300 lines. Everything else is helpers. At the highest level, nanoGPT takes a sequence of token integers, passes them through an embedding layer and a stack of transformer blocks, then projects back to vocabulary logits. Before tokens enter the model, raw text is encoded with a byte pair encoding tokenizer. For GPT-2, that means a vocabulary of 257 subword tokens. nanoGPT pads this to 304, the nearest multiple of 64, for GPU arithmetic efficiency. The GPT config data class holds all model hyperparameters. For the 124 million parameter GPT-2 baseline, 12 layers, 12 attention heads, an embedding dimension of 768, and a context window of 1024 tokens. The model holds 2 embedding tables. WTE maps each token ID to a dense embedding vector, and WPE maps each position index from 0 to block size. They are summed element-wise before the first dropout. Causal self-attention is the heart of the model. Queries, keys, and values are projected from the input in a single batched linear layer, then split and reshaped into multiple heads. The attention score between each query and every key is scaled by 1 over the square root of the head dimension d sub k, then masked so each position can only attend to earlier positions, making the attention causal. The MLP sublayer expands the embedding dimension by a factor of 4, applies a GELU nonlinearity, then projects back down. This feed-forward layer is where the model is thought to store factual knowledge learned during training. During training, the loss is the cross-entropy between the model's predicted logit distribution and the actual next token at each position. This is the standard language modeling objective. Maximize the probability of each token given everything before it. At inference time, the model predicts 1 token at a time. It runs a forward pass, takes the logits at the final position, scales them by temperature, optionally keeps only the top k candidates, then samples from the resulting probability distribution. Temperature scales the logit distribution before softmax. Lower values make the model more confident and deterministic. Higher values produce more diverse output. Top K sampling further narrows the vocabulary to the most likely candidates. The training loop is a standard PyTorch while loop. Each iteration. Set the learning rate, optionally evaluate and save a checkpoint, run the forward and backward pass with gradient accumulation, clip gradients, then step the optimizer. The quickest demo is training a character-level GPT on Shakespeare. 1 megabyte of text, 6 transformer layers, 384 dimensional embeddings, about 3 minutes on an A100. The validation loss reaches about 1.47, low enough for plausibly Shakespearean output. For a more serious benchmark, nanoGPT reproduces GPT-2 at 124 million parameters on open web text. The training loss curve shows steady descent over 600,000 iterations, reaching a validation loss around 2.85. GPT-2 comes in 4 sizes from 124 million to 1.5 billion parameters. nanoGPT evaluates all 4 on open web text to establish baselines. Note that GPT-2 was trained on OpenAI's closed web text, so these scores reflect a dataset domain shift. Key numbers from a full nanoGPT run on GPT-2 at 124 million parameters. Roughly 600 lines of code, 4 days on 8 A100 GPUs, and a validated reproduction of GPT-2 performance on the open web text benchmark. Compared to production-grade libraries, nanoGPT deliberately omits features like rotary position embeddings, tensor parallelism, or full evaluation harnesses. But every feature it does have is easy to locate, understand, and modify. nanoGPT is intentionally not a library. It is a codebase meant to be read and modified. The philosophy is, keep the whole model in your head at once so that hacking and experimenting require minimal indirection. nanoGPT. From token embeddings to causal attention to distributed training and pre-trained weight loading, the clearest window into how modern language models actually work.